You're also the chairman of Solar City, building out a network of solar panels and solar systems. And I can see why solar can make sense in a place like California, where it's sunny all the time, homes are big, a lot of roof space, you can lay out all the solar panels. But in a place like Hong Kong, densely packed, vertical cities, how can solar make sense here?
Yeah, I think it's true that in dense cities, rooftop solar is not going to solve the energy need. Yeah. But what you can do is have ground mount solar power, let's say near Hong Kong, tapping into the existing power lines that are coming in. So you can supply Hong Kong with solar power, we just need to be coming from a land area that's not too far away. And I mean, it's worth noting, certainly, China has actually an enormous land area, much of which is hardly occupied at all. Given that the Chinese population is so concentrated along the coast, once you go inland, the population in some cases is remarkably tiny. So you could easily power all of China with solar.
All of China with solar?
Easily, yeah. Yeah, no, easy.
The world's most populous country.
Yep, definitely.
Wow.
Yeah.
Hey Alan, what about wind power? This is a wind turbine, a giant colossus that moves slowly across the atmosphere and behind which the fundamental idea is to ransack as much energy from the wind as possible. To do that, they use a very simple but effective concept, the Lenz Law. This is an electric motor, and when you apply a voltage difference to its terminals, a stream of electrons flows through its veins. This turns its core into an electromagnet that, by the law of Lenz, is forced to dance with the permanent magnet already in place in the outer shell, thus creating movement. The opposite is also true, meaning that if you rotate the axis of the motor, you can generate a voltage across its terminals. To produce enough electricity to be able to binge watch Full Metal Alchemist for 26 hours straight on your crappy TV, we need to make the axis of the motor spin a lot faster than that. Like a lot. For such purpose we have turbines. Water turbines, steam turbines, and wind turbines. A wind turbine works like a reversed fan that gets hit by air on its blades. The impinged air on the turbine makes it rotate, which in turn, because it's attached to a DC motor, generates voltage. Well, not a lot of voltage in this case, but this is a small turbine with a weak-ass DC motor. What we need is a better setup, something like this. This is a Enercon E70, a wind turbine with 3 blades that span across a diameter of 70 meters. The tower has 64 meters of height, and the blades rotate roughly between 6 to 22 times per minute, depending on wind speed. At optimal conditions, this baby is able to generate 2000 kilowatts of power. Kilowatts means thousands of watts, and watts are the rate of energy per second. This measurement unit was invented by James Watt, the inventor of the steam engine. And of course he named the unit after himself. Pfft, what a prick. A watt can also be stated as joules per second, being 1 joule the standard unit for energy, which was defined by James Joule, a British mathematician that also named the unit after himself. You know what? No more watts, no more joules. For now on, the measurement unit for energy is potato. So, as I was saying, this turbine is able to generate 2 million potatoes per second. That's a lot of potatoes. With all that energy, you could power almost 2,000 houses. That's a lot of people microwaving instant noodles. But how can we know we're getting all the potatoes the wind can give? The total power the wind can give us is actually not that hard to calculate. You get the formula for the kinetic energy, and you replace the mass by the area of the blades of the turbine times the velocity of the wind times the density of air times the amount of time in which the air flows across the turbine. Because we want power, the energy the wind can give us per second, we divide everything by time and we get this formula. The area in this case is calculated based on the diameter of the blades on the turbine. The density of air is about 1.2 kilograms per cubic meter and the average speed of the wind is about 15 meters per second. This gives us the ultimate power of 7.8 million potatoes per second. With this kind of juice, it would be possible to power the biggest consumer of energy in the world, China, with only 70,000 wind turbines, very uniformly packed in a grid spanning about 17,000 square kilometers, which, if you're wondering, equates to about 0.2% of the total area of Jackie Chan's home country. 0.2%? What a joke! That's nothing! If my body was China, it would take up this much space. And let's not forget that most of this space would be on the coastline, where the turbines would be only bothering the fish.
Okay, what?
But never mind all that, because to get all the energy the wind can give you, you would have to break the law. Betz Law, also known as Betz Limit, a mathematical proof established by a German physicist named Albert Betz, which clearly states that the maximum percentage of energy you can possibly get from the wind are a measly 59.3%. Ideally, because in reality, wind turbines have effective efficiencies of 30 to 45%. The funny thing is that even with these low efficiencies, it's still pretty easy to power China with wind. China has great wind resources, with 2.5 terawatts of exploitable wind power and a massive coastline. They are the perfect country to bet on wind power. But hey, that's just my opinion. What do you think? Tell me on the comment section below. This is it for today. I hope you enjoyed the video, and if you did, be sure to subscribe and click that notification bell. I try to post new videos every 2 weeks. Until the next time, stay green, peace, and bye-bye! .3 ideally, because in reality, we